Today we're going to start talking about finding the equation to a line tangent to a graph. So I'm going to start with this equation, 3x squared minus 7x. It's a standard quadratic function, a little bit of shift to it. So what we're going to look at is I've taken my TI-83, my emulator, and I've plotted 3x squared minus 7x. And I've modified my window a little bit to show the aspect of the graph that I think is important. So my x-min is 0, x-max of 5, y-min of negative 5, y-max of 0. What I end up looking at is this quadratic. Now, I'm trying to find the equation of a tangent line. So the first thing that I need is a point. So I'm going to calculate the value at x equals 1. And I can see when x equals 1, my y value is negative 4. That will come into play later. So the first thing I want to do is I want to find the slope of that tangent line. And I know that the slope of the tangent line is the approximation for slope of the function. So what I turn to is the limit definition of the derivative. So as I said, here's my function, 3x squared minus 7x. What I'm going to do is set up my limit definition. You'll see here I have limit h approaching 0, f of x plus h minus f of x, all divided by h. Here I've substituted in my x plus h and my x into the function 3x squared minus 7x. So here's 3 times x plus h, the quantity squared, minus 7 times x plus h, minus the original function, which was 3x squared minus 7x. Now, all I'm going to do in this next step is I'm going to expand it and I'm going to simplify it. So you'll see what I have here is 3 times, this is just x plus h, the quantity squared, still minus 7 times x plus h minus 3x squared minus 7x divided by h. Now I'm going to go through and distribute. Remove all of my brackets, 3x squared plus 6xh plus 3h squared minus 7x minus 7h minus 3x squared plus 7x divided by h. Simplify by removing anything that cancels out. For instance, this 3x squared here and the minus 3x squared here will cancel each other out. And I'm left with a numerator of 6xh plus 3h squared minus 7h. This is still divided by h, so I'm going to go through and cancel an h from each one of my terms, and I'm left with 6x plus 3h minus 7. As I substitute in 0 for h, this 3h disappears, and I'm just left with 6x minus 7. We call this our derivative. Now what we're going to use the derivative for is to calculate slope. So I'm going to remember I'm using the point 1, negative 4. So when I substitute 1 into my derivative, I get a slope of negative 1. So that's fine. I have a slope for my tangent line, and I have a point. Now I actually have to go through the process of finding the equation. So if I slide down here, this is what I know. I have the slope of negative 1. I have the point 1, negative 4. So I'm going to use my point slope formula, and I've modified it a little bit by moving y1 to the right hand side to simplify what we're going to ultimately end up doing later. So y equals m times the quantity x minus x sub 1 plus y sub 1, which is our point slope formula. I've substituted in the values I know. For m, my slope, I've substituted in negative 1. For x sub 1, I've substituted in my x value of 1. And for y sub 1, I've substituted in my y value of negative 4. Now all I have to do is simplify. I get y equals negative x plus 1 minus 4. And this simplifies to y equals negative x minus 3. Now, this is the equation of my tangent line. But what I want to do is I want to go back and look at this, and I want to put in this equation and see if it really is a tangent line. So I'm going to go into y equals, into y sub 2, and I'm going to put in negative x minus 3. Now if this is a tangent line, what I should see is that this line will cross my quadratic function at the point 1, negative 4, and not touch anywhere else. So let me go to my graph. And I do not see an equation. So, why, oh why, where is my graph? You know what? This is the kind of problems that we get. So, let me zoom 6, see if it appears. Aha! So, let's see what happened. This is negative x. Ooh! I put negative x times negative 3, so let's change this to subtraction. And make sure that that works a little bit better. Ah, more like what I was looking for. So let me go back to my window settings. Alright, x I want from 0 to 5. I want this to be from negative 5 to 0. When I graph, I should see my tangent line come and touch. And just to make sure, because I want to know exactly where this touches, I'm going to go to second, calculate, the intersect, which is 5, my first curve, my second curve, my guess, because I never guess. And it's thinking, and my intersection is 0.99999999956, y equals negative 4. Now, this may throw you off a little bit because you look at that and you say, well, that's not 1. But remember that the calculator graphs in pixels. So it may not have 1 as one of the pixels it actually calculates. But if we look at this number, 0.999999956, I would say that most people will agree that that is pretty much equal to 1. So insofar as our calculator will show us, this is showing us an intersection of 1, negative 4. Alright, so that's what you need to be able to do, and we will probably work on it a little bit in class tomorrow, which is Monday, and a little bit more on Wednesday. So, this is your teacher, signing off.